Would you like to get the chance to win a ROS developer shirt and practice some ROS along the way? Then stay with me. This video is for you. Hello ROS developers, I am Alberto and welcome to the Solving the ROS Challenge of the Week video series. So for those who don't know it, who are new on this, the ROS Challenge of the Week is a challenge presented by us, by the construct, where you are presented with a ROS-related problem with different difficulties. We have beginner, intermediate and advanced. And this ROS-related problem needs to be solved by you. Yes, using your ROS knowledge. And the quickest solver gets a ROS developer's t-shirt. So today, in the video today, I'm going to show you which steps you should do in order to solve one of our challenges. So the first thing of all would be to get the project. You can do so by clicking on this link. So that's what I'm going to do right now. And by clicking on this link, I will have this challenge, this ROS project in this case, which is this one, automatically copied into my workspace. Yes, you will have it like this if you are already logged in. If not, you will have to log in. And if you don't have an account, you will have to create an account, which you can do free in just 1 minute or so. So yeah, once you are in your account and you click on the link here, on the link of the ROS project, then you will have this project, as we name it, here in your workspace. Yeah. Then the next step will be to open it here. Click on the open project, and this will start opening the environment with your ROS project, which we are going to see right in a moment. But meanwhile, this loads. It will take some seconds. Let me remember you a couple of things. First of all, the challenge of this week is number 6, and as you can see here in the title, it is an intermediate level challenge. So it's between the beginner and the advanced level. You will see this one, it's not very difficult, to be honest. I would say that it's pretty easy. You just need to know a little bit how ROS services work and a little bit about understanding the messages structure. We will see right now how to solve it, but you will see that it's super easy. In fact, I have been reviewing some of the solutions that you developers have sent us, and many of you have found a solution, so you have actually solved the problem, but you have done it in a harder way. Yeah, so you will see now how I will solve it, which is quite easy. But before this, let me remember you to have a look and visit our academy, our Robot Ignite Academy. You can come here from ROS.ds clicking on the ROS courses webpage. This will take you to our Robot Ignite Academy, where we have many ROS-related online courses, as you can see here. Where you will have to learn ROS and practice ROS using simulated robots. You don't need to install anything on your computer. You have everything in the web browser, as you can see. And you have many different topics like ROS Basics, where you will learn about ROS services, for instance, ROS Actions as well, ROS Topics. You have courses for ROS 2, Python and Linux courses for the fundamentals, which are free, by the way. You don't need to pay anything in order to complete these courses. We have our new developing web interfaces for ROS, which will show you how to create web pages that allow you to interact with ROS, like for instance to move a robot, to control a robot, to perform navigation, etc. Deep learning as well with domain randomization. Here, unit testing, how to perform unit tests with ROS. Well, many courses, as you can see. So have a look at them, because with all this knowledge, it will be much more easy for you to solve our challenges. For instance, for this one, for the challenge of this week, the proper one would be, I would say, ROS Basics in 5 days, because it will give you the fundamentals about how ROS services work and also about the messages structure and how to understand the structure of a specific message. So yeah, here you have the Robotics Academy. I will leave a link as well to the Academy in the video description. And now let's come here, which, yeah, our project has already loaded, as you can see. So yeah, once you have your project loaded, so remember the first step would be to grab it here, clicking on the link, then next step to open it. So now all you have to do is you will have automatically opened the Jupyter notebook. All you have to do is to follow the instructions indicated here in the notebook. So here you have some basic instructions about how it works. Then what we are going to do now is to start the simulation. So for this, we need to come here to the simulations menu, as you see here, and click on the choose launch file. And then here we are going to select the ROS project of the week 6.launch and click on the launch button. Why this one? Well, because it's indicated here in the notebook. Yeah. So here it says, hey, come here and select this one, the project of the week 6.launch. Then after some seconds, the simulation will load and you will get something similar to this with a Husky robot here in a playground, let's say. And after we have our simulation loaded, which is going to be right now, I think, yeah, almost there, 90%. Yeah, so here we can see our Husky robot loading, almost there. All right, so here we have our simulation, excellent. As you can see, it has loaded here, so let's leave it at the right side, some here. Okay, so now here we have described the problem to solve. So basically he says, hey, in your Catkin workspace, you have a package named project of the week 6_package. So for this, I'm going to open the IDE, which will allow me to visualize my files. And here inside the Catkin workspace, I can see that I have this project of the week 6 package. Yeah. Then this package contains a couple of Python scripts. Let's see. Yeah. So here we have them: get post service and get post client. These two. So here you have these Python scripts, and the main purpose. Let's click here. So the main purpose of this service is to be able to get the pose, position, and orientation of the Husky robot when called. Okay, so how can I try this? So first of all, let's open one shell. Here, we are going to source our workspace, first of all, so I can copy and paste the command directly from here. Next step will be to start our service server, which we can do so executing this command. So let's do this. And here we are running our service server. And now we need to launch our service client in order to call our service server, which we have running here. So for this, let's open another shell, and we are going to execute our client right here. As I've said before, this service server, service client, all these concepts are related to ROS services, so you should know a little bit about services in order to understand this. So basically here I have my service server, and now I am going to execute my client here, and the client, what it's going to do is to basically perform a call to this service server. Yeah. So let's execute our client, get post client, there we go. And we are getting an error. Okay, yeah, so if you are familiar with these ROS challenges, you know that anything works at the first try. So you will always get some kind of error. So now, what I need to figure out is what this error is, yes? Because the expected behavior is to get here printed the position and orientation of the robot, which obviously it has not happened here in our, we don't get this printed here. So we need to figure out what's going on here so that we can have this behavior at the end, yeah? Okay, so let's go for it. So first of all, I can see here that it says type error. Request object is not a valid request message instance. Okay, so basically in services we have two types of messages involved. One is the request, let's say, and the other one is the response. Yeah, the request is the message sent from the client to the server because you are requesting something to the server. Yes, that's why it's called a request. And then whenever this request is performed, is sent to the server will do whatever it has to do, and it will return a response to the client. Yes. So these are the two messages we have: the request, which goes from the client to the server, and the response, which goes from the server to the client. Yeah. And here it's saying that the request is wrong. So here, the problem, we should come to the client and see here what we are doing in the code. So as you can see, it's super simple code. So basically here we're importing ROS-by, we're importing the empty service message from the standard services package. Then here we are initiating a node. Here we are waiting for the service, which is getPost service. Then here we are defining our client, as you can see, which will connect to this getPost service. This getPost service name is defined here when we define the service server, as you can see. We will check this file later. And we say that this service will use an empty messages, which the one that we are importing here. And finally here we are creating the request. But here there's a problem. So whenever we work with service messages, you should know, in order to understand this, that we have three different type of messages, let's say. One is the empty, which makes reference to the whole message, yes? And this is the one used here in the declaration of the client and also in the declaration of the server, as you can see. And then we have two other additional messages. As I've said before, one is the request, which is named like this. It's the name of the message plus request, like this. And then the other one is empty response. Yes, as you can see here as well from the service server code, here we are returning a response, empty response, yes? And we are importing empty and empty response as well, yeah? So, with this, here we are not going to use the response because it's only used in the service server side, but we do actually need to use the request. Yes, so here we need to import as well the request message. Yes, and then when we create our request, which is here, we need to use not empty but empty request. Oops, sorry. There we go. Yeah, so here we are defining this variable as an empty request object. Yes, and then I'm going to send this empty request object, which is this variable, as you can see here, to the server, like this. Yes, so let's try. Now that we have figured out this and fixed this, let's come here, save our code, and try again the whole process. So let's run first. Oh, we already have it running. All right, so let's try to call it again, execute our client, and as you can see now, the client has worked properly, and here we have the message in our server, but as you can see, this is wrong. Yeah, so here we have too many things, and what we are expecting to have is this. It's just the position and orientation of the robot. And here we do have, in fact, the position and orientation here, but we are seeing as well the header, covariance, also twist values here. So there is something wrong here, but in this case, the error is in the server side, yes? Because we have fixed here our client, so we have performed correctly the call, yet the request to our service server, but here in the server side, something is going wrong. So let's come now here to our server. And here, as we can see, we are also importing empty and empty response. So this is correctly. We are importing here the post message and post with covariance stamped to a couple of messages, and also odometry message. Then here we're defining a post, a variable, which is this robot post, a global variable in this case, that is going to contain a post message. And then let's come here. So first of all, we define the node, the ROS node. Then here we are defining the service server, which will be called like this, getPost service. It will use empty type of message that we are importing right here as well. And it will have a service callback. What is this service callback that we have defined here? What is this? Well, basically it's that whenever we do a request, we send a request from our client to the service server, this callback will be triggered. Yes, this service callback. then this will come here and will print the robot pose, this variable that we have defined here, which at this moment is empty. Yes, and then it will return an empty response. Yeah, so this is correct. And here we have a subscriber. So this here we're defining a basic ROS subscriber that will subscribe to this topic, odometry filtered, which uses odometry messages and which has this callback, this sub callback. And this callback basically what it's doing is to grab this robot pose global variable that we have defined here, and it puts the message into this variable, the wall message that is published into this odometry filtered topic. Yeah, and this is where we have the error. So if we come here and have a look, ROS topic echo to the odometry filtered, if you have a look here at one message, we will see that it contains many fields. In fact, it contains the same fields that we were getting here as a response. Yes, you can see that. So let's have a look here at the message that this topic uses, and this is an odometry message. Yeah, as it is stated here, this topic uses an odometry message. So now, if we come here and have a look at the odometry message, we will be able to see the structure of this message. Yes, which are the different parts of this message, and we can see it here. So basically this message has a header section, which is here, a frame ID as well. Then it has this pose section, big section here. Oops. Let me come here, this pose section, as you can see here, which contains the pose, which contains as well the position and orientation, and also a covariance value here. Yes, and then below we have twist and everything. But let's stop here because we are interested in getting the position and orientation. Yeah, and as we can see, these two messages, the position and orientation, are contained inside this bigger pose message here. Yeah, so what do we need to do now? So basically now, in order to access this message, we have to go layer by layer, let's say. Yeah, so the message variable, this message variable that we have here, yes, that we are getting here, this message variable will contain the wall odometry message. Yeah, and then we have to enter inside this message layer by layer. So first of all, we need to come to the first layer, which is this one. As you can see, it doesn't have any indentation, which means that it's the higher layer in this case, at the same level as this one, as the header and also the child frame ID. So the first thing we will need to access is this pose message. Yeah, so here for this we are going to do message dot pose. Yes, so with this, basically, let me do this bigger. What we have done is to access this wall pose message. Yeah, but this bigger pose message contains the covariance as well, which I'm not interested in this case. So I need to still enter another layer here to this second pose. Yes, because this one is the one that contains only the position and orientation. So I'm going to do yet another dot pose. Yes, so now I am from the wall message, I am getting just this pose variable, which contains, as you can see here, the position and orientation. Yes, so great. So let's save our code and let's execute one more time. Let's execute one more time here the server. Here we have it, and let's perform one more time the request, executing the client, and now we do get the position and orientation only, as you can see here. Yeah, so as you have seen, it's pretty simple. Yeah, it's an intermediate level because you need to know a little bit about ROS services and about message structures, but as you can see, you can solve it super easy. You just need to know some basic concepts about ROS services and some basic concepts about ROS messages, yeah. But yeah, that's it. So I hope you have liked the video. I hope many of you have managed to solve it properly. And stay tuned for future challenges. So today, alongside with the video, we are going to publish the new challenge for next week, which, by the way, it's going to be an advanced challenge. Yeah, so this one will require some more ROS knowledge. It will be a little bit trickier, but I'm sure you will be able to solve it as well. And yeah, let me just remember that in order to, whenever you have solved your project, you will save it and everything, and you are going to share it in Twitter using this structure as you have explained here. And let me remember you that make sure that before you share your project, you make it public. Yes, you have the steps explained here, but make sure that you make it public, because otherwise, if you have it private, the share link will only last for 24 hours. So after a week, which is when I have a review of all your projects in order to see which is the winner, your links won't work anymore because they will be dead after 24 hours, yeah? But if you make your project public, then they will last forever. So there will be no problem for me to be able to review your projects, yeah? So this is an important part I wanted to remember all of you. And yeah, this is all for the video of today. So yeah, see you in the next video. Goodbye and keep pushing your ROS learning.